All right, so calculus, we're going to talk about combining functions, shifting, and scaling graphing. This is all review, okay? So this is stuff that we've talked about in other classes. So hopefully you start remembering this stuff and it's starting to be refreshed. So f plus g of x is f of x plus g of x. F minus g of x is f of x minus g of x. The product, f times g of x equals f of x times g of x. And then the quotient, f over g of x equals f of x over g of x. And g of x cannot equal 0. So here's our f of x, our g of x. We're going to work through each of these kind of as an example so we can see. So we're going to do the plus. Okay, well that becomes the square root of x plus the square root of 1 minus x. Probably should have some domain restrictions. Notice here that we can plug in 0 here, but we can't plug in 0 here. So if I look back over here, my domain here is values greater than 0. So I have 0 to infinity. And here I have 1 to infinity. So when I add these together, I have to take that domain that is the most restrictive. Okay? So this is more restrictive than this one, so my domain would be from 1 to infinity. Okay? So we're not going to put those in here. I just wanted to talk about that because that is going to kind of dictate what happens here. All right, so f of x, so I have the square root of x minus the square root of 1 minus x. Now I have the product. Square root of x times the square root of 1 minus x. I could bring this together and make this the square root of x minus x squared. That's fine. I'm going to leave it like that just because I'm trying to save some time. So this becomes the square root of x over the square root of 1 minus x. Once again, in this case, I need to be even a little bit more restrictive. Okay, so 1, I could plug 1 into g of x, but the problem is if I plug 1 in here, I now end up having a 0 here. And so my domain here would actually be from 1 to infinity, okay? So just be careful with that. We want to make sure that we understand that there is domain restrictions in all of these, okay? I'm going to go ahead and rationalize that denominator. So I get the square root of x times 1 minus x, square root of x, all over 1 minus x, okay? So, yeah, I could bring this into one single square root. That's fine. We're going to talk about composition of functions now. So if you remember composition of functions, that's essentially taking one function and plugging it in as the x of the other. So if you remember kind of Fogg and Goff, okay, so this says f of g of x is equal to f of g of x. So we're going to take the g of x and plug it into the f of x, okay? Or if we're looking at this notation here, we're going to kind of work right to left. I'm going to take the x, plug it into g, take that answer, plug it into f of x. So one of the things to understand in composition of functions is I have this domain and range for g of x and f of x. Well, when I take g of x, my range of g of x becomes the domain of this function here. Okay, so now we're just gonna kind of look at some composition of functions here. So here's this is f of g of x. So I'm gonna take my g of x and plug it into my f. So here's my g of x. I'm gonna take it and plug it in for my x. So this becomes x plus 1. A lot of times I'll put parentheses around this just to show students, where I put this whole thing in for x. You don't have to do that. It's just something to kind of look at. Okay, now the next one says I'm going to take f of x and plug it into g of x. So I'm going to take this square root and I'm going to plug it in for the x here. So this becomes the square root of x plus 1. Okay, now I have f of x. So I'm going to take f of x, I'm going to plug it in to f of x. So I'm going to take the square root of x and plug it into the square root. So I have the square root of the square root of x. Now I have g of x. I'm going to take this x plus 1. I'm going to plug it back into this x. So this gives me x plus 1, which is x plus 2. So that's composition of functions. Hopefully you guys are starting to remember, combining functions and compositions of functions. Now we're going to look at shifting. Shifting and scaling our graphs. So if I have a vertical shift, I'm going to add on the outside of the x. So the f of x. So y equals f of x plus k. So that's going to shift me up and down. Horizontal shift, I'm going to go inside. So y equals f of x plus h. So that's going to give me a left or right. And remember, when I'm inside these parentheses, it's always kind of the opposite direction. So if this is actually plus h and h was a positive number, this is actually going to shift left. Okay? So kind of an example of that, here's my f of x equals x squared. If I want to shift up 1 unit, I'm going to go x squared plus 1. Okay? So that gives me that vertical shift of plus 1. Okay? If I want to go up 2, we're going to make this g of x. What I'm going to do is I'm going to take that 2, I'm going to plug it in here. So x minus 2, because remember, I want to go right. So it's opposite sign. So inside this is what makes it 0. So that's going to be right 2. So if I was down 3 and left 1, so I want to do both of these, okay? So now what I'm going to do is I'm going to go h of x, just to give you kind of like, so you don't get confused that it's the same graph. Okay, left 1 says I go x plus 1 squared, down 3 says minus 3. So now I'm going down 3 and left 1. Vertical, horizontal scaling and reflecting. So if you remember back when we talked about graphs, we talked about stretching them or shrinking them or compressing them. And that's what we're going to talk about. We're going to talk about the case where c is greater than 1. Okay, we don't want to talk about 1 because if I multiply by 1 times the function, it's just a function. And we're going to use this idea that c is positive because negative c does something else. Okay, so if c is greater than 1, and I have c times f of x, that's going to be a vertical stretch. So what's going to happen is, as I have my graph in here, so if let's say I have a generic x squared, if c is greater than 1, it's going to end up stretching it. It's going to pull it up, okay? Now, if I have 1 over c times f of x, what that's going to do is that's going to compress vertically. So now I have this kind of idea where it's kind of compressing it down vertically. Okay. Now, if I take that same c and I put it with the x, so now I'm multiplying the x, I have a horizontal compression. So what's going to happen is that I'm going to compress that horizontally down. If I divide by c, I have a horizontal stretch across there. The big one is what happens when c is negative. Okay, so if I have a negation, negative f of x, what's going to happen if I put the negative on the outside? It's a reflection across the x-axis. If I put it inside, the negative x, that's going to be a y-axis reflection. So what we want to kind of look at is how do these change? Okay, so we kind of looked at this. Let's look at, let's go f of x equals x squared. That's a nice Okay? So here's my x squared. Okay? Now, if I take and I were to say, okay, well, I'm going to put g of x is going to be 2x squared. So now I'm going to multiply this by 2. So every single of these y's is going to be double. So what's going to happen is I'm going to come in here and I'm going to have a vertical stretch because now c is positive, I'm over this. Okay? If I take h of, and I go 1/2 x squared, now what's going to happen is I'm going to divide all these y values, or multiply all these y values by 1/2. And so they become half of that. Okay? So that kind of gives you this top part again. Now what happens if I take the same idea, okay, and I now look at something like this. Let's say I'm gonna take this first idea and I'm gonna multiply this by 2. So now what I'm gonna do is I'm gonna take g of x and I'm gonna say that that is 2x squared. Well, 2x squared becomes 4x. Okay? So 4x is even gonna be steeper than the 2x, so it's gonna be nice and steep here. But if you notice, horizontally, I've compressed this way. Okay, and that's what it's talking about. So now if I look at, okay, I have h of x, and I'm going to say that that's x over 2 squared, which then becomes 1/4 x squared. Well, 1/4 is taking this and really making it shallow out. Okay, so that's a vertical compression. Well, what happens if I now take and I say, okay, I want to go, I'm going to erase this orange one here. And I'm going to go g of x equals negative x squared. Okay, so that's this one right here. What's going to happen is I'm going to take all these values and they end up being reflected. Now, sometimes we can't tell if it's an x-axis reflection or a y-axis reflection depending on our equation. X squared is not very interesting for a y-axis reflection because if I plug in negative x here, what happens is these values end up over here and vice versa, and they're the exact same values. But hopefully that helps you understand, combining functions, composition of functions, and then that vertical and horizontal shifting plus scaling.